Welcome. This is Echo B2000 Intro to Econometrics here at the Department of Economics and Business in the Colin Powell School at the City College. We're going to have fun. Now, statistics is ultimately used for persuasion. First, we want to persuade ourselves whether there's a relationship between some variables, typically. Next, we want to persuade other people if there's some relationship there. Now, sometimes statistical theory can be quite platonic in sort of insisting there's some ideal coefficient or ideal relationship to be determined, some capital T truth. In this class, we'll try to keep that sort of discussion to a minimum while keeping the persuasion rationale uppermost. So, much empirical work is currently in crisis from a lot of well-known studies not replicating. Sometimes they're outright fraud. But the bottom line for many researchers is low p-value leads to publication. There might be a few who simply accept that causality. Many more would defend a somewhat more cynical view that other people believe that, so they have to play along. We'll talk about some of the rationale for why that view became common over the past century of scientific research. But still, sometimes people's view of research reminds me of Bitcoin mining. In both, somebody starts with a bunch of numbers, processes them through some series of computations that they don't really understand, and then if a certain pattern is discovered, hey, that pattern has value. Whether that pattern is a few low p-values or zeros in a hash. Researchers, I think, should be more concerned with understanding their data. So to understand data, we're going to explore techniques in data visualization, thus the text. We'll use the book, Data Visualization, I know, good title, by Kieran Healy. You can buy the book, depending on your preferences regarding dead trees, but it's also available online for free, and there's a lot of material in his GitHub page. Data Viz requires a basic understanding of stats, thus the also additional requirement for Hawks. Now for Hawks, most of that should be review, so I'll only go over that material from a pretty high level. This class is meant for students who have a decent background in basic stats. But in my experience, many students don't know if they have a decent background in stats. That's the whole problem. So there's a diagnostic test a few weeks into the semester that you take online. The online material lets you review, since I know some students haven't done stats in a while and have to do some mental archaeology. Scrape away some of those layers. The diagnostic test will only count for 10% of your grade, but if you do poorly, then we should talk. You got to purchase access to the online Hawks learning system in order to take the test. The system gives you straightforward explanations of each topic and allows you to do lots and lots of practice problems, which is the best way to ensure that you learn these topics. So go to hawkslearning.com, enter your school, it's CUNY, the City College of New York, and find beginning statistics. I've set it up with recommended practice sections, but you can explore more. You do it at your own pace. Some might want to get an early start. Each chapter has practice problems, and then there are 2 additional practice exams you can take as many times as you'd like. Your score is recorded, but it doesn't count in the grade. It's just FYI. Practice number 1 is a little easier. Practice number 2 is a bit tougher than the actual diagnostic test. You have only one chance to take the actual test before the deadline, so find a time when you have a couple hours to go through it. There is a strong correlation between doing lots of practice and performing well. There's not a mystery there, it's just you got to put in the time. In this class, we're going to be using a computer program called R, and we're going to use R Studio, which kind of sits on top of R, like a skin or something. One of the first things you got to do is install each of these bad boys. So how do you do that? You go to the link that I put there, it's from the web page as well, and you follow the instructions. Step 1, download and install R. Step 2, download and install R Studio Desktop. I can't give you better exact instructions because that depends on your operating system and your computer setup. I happen to be using Windows machine, you might have an Apple or some other kind of Linux or something. So the instructions are going to be variable for each person. I'd love to give you better step-by-step details, but I can't because it's all different. So pause here and try it. You can contact me if you're having trouble. Happy to get on Zoom and help you through step by step. But I think most of you know how to install a program, or in this case, 2 programs, R and RStudio. Once those are installed, you'll only need to open up RStudio, and that automatically opens up R kind of beneath it there. I've put notes online, linked from the class page. You can find details there. Now, as we go through writing code, let me caution you, ChatGPT and similar can really speed up coding, but first you got to understand the basics, or else you'll just be speeding up as you crash into different barriers. First, you got to build your understanding. Otherwise, it's like going to a gym and asking, why is everybody lifting these heavy weights when you were just using their muscles? Come on, man, just use a winch or a machine or something. Isn't that easier? No, that's not how you build it up. Anyway, so you run RStudio, open it up, you'll see there's 4 different panes of the window. And the one we're concerned with, that's the one with the big green arrow. Yep, down at the bottom, that's the one. The other pages will be useful in a bit, but not right at the start. You could run some commands right there from the green arrow there. Or alternatively, you can type commands in the window just above it and then run those, which basically is moving the commands from that top window down to the bottom one. There are more details in the file that I've attached to the video. Now let me show a couple of examples of graphs that I've recently created. Working with the Social Mobility Lab here at the Colin Powell School, I've been looking at different data about the differences in various life outcomes for people with college degrees. This graph shows average wages earned by people with different undergraduate majors, 2021, with data from the Census Bureau American Community Survey, selecting 3 particularly high-earning majors: economics, engineering, which includes civil, mechanical, electrical, and computer science. You can see the typical hump shape of wages. I like the graph for the balance between simplicity and complexity. The simplicity is this is not using any fancy model. This is just looking at the average wage for people of a particular age and major. I mean, there is some smoothing being done, but the bands show the statistical uncertainty. It's not that substantial. So you can read off the numbers from the left-hand side. That's just annual salary. But there's complexity there too, right? If you look at younger ages, you can see that early on, CS majors earn more, but the other majors catch up and surpass as people got older. That combination of simplicity and complexity is meant to entice the audience to ask more questions. Well, why this pattern? I mean, it looks like economics majors edge out engineering majors. How certain can we be about that? Could there be an issue where CS majors, I don't know, maybe they're more likely to retire early, so their measured wage falls? The graph inevitably muddles different influences. People who are older typically earned a college degree a couple decades ago. So the difference in wage trajectories could be due to their initial degrees or various influences over time. The returns to CS degrees, for instance, might be more cyclical. I don't know. Meant to ask or prompt people to ask more questions. Here's another graph. Again, age on the horizontal axis. This time the vertical axis shows how often respondents said they were depressed in the last 2 weeks. Higher numbers are worse. Now, the numbers aren't exactly numbers of times. It's just, they're more saying like 4 codes to nearly every day, whereas 1 would be just occasionally, 0 is not at all. So I group people by completed education, whether they have a 4-year degree or more, whether they have some college but not a 4-year degree, or whether they have a high school diploma. Again, I think the mix of simplicity and complexity is useful and, I hope, intriguing to the audience. Mental health improves as people get older. All the lines are trending down quite sharply. That's probably the first thing you notice. But the separation is also clear. People with a college degree, those are on the lower line there. They have much better mental health than those without that degree. Although there's less of a gap for the very young and the very old. But that gap is sizable. A college grad who's about 30 has same mental health as a high school grad at 55 or so. Now, this should pique questions. Why that correlation? What direction might be the causation? I mean, maybe people with worse mental health are less likely to get a degree, or maybe people who got a degree can attain better mental health. And if it's that latter explanation, is the cause from just education, or is there more about income? College degree causes higher income, which causes better mental health. And what other factors are we omitting that might be important? Lots of good questions. So we're going to try to learn some ways to answer those. So we get some data. Go to the class page. There's a link to download some of this data for the class. Start with the household pulse data, the one that I've got that giant arrow there. Yeah, that's one. That's the one to download. Now, again, downloading could be a bit of a pain because details depend on your particular setup and OS. The data are going to be zipped. So step one, you got to unzip it before you use it. Now, it's probably going to get just thumped into your downloads folder, which may not be the place you want to leave it, because R is going to go look for the data in a particular folder, and you have to somehow match that up. You got to put the data where R is going to be looking for it. So you got to understand a little about the directory structure of your operating system and where your folders are. You got to find your own balance. Perhaps you're just starting off, you don't make it too hard. But on the other hand, you're going to be doing this for a while, so there's opportunity to do it right. In 3 weeks from now, you don't want to be back like, why did I do this crappy way and I could have done it better? And you have to go back and redo it. Think of it as an investment. But still, everybody's computer is going to be a little bit different. So when you load up R, it's going to be looking for files in a particular directory. Minor note directory, folder, different words for the same concept, just different operating systems have different terms for it. Folder, directory, whatever you want to call it. It's the place where the data is going to be located. R is looking in one place, your data ends up in a different place. You got to make those match up. So right at the beginning, you have to understand how those little directories, different ones work. Now, fortunately, in RStudio, there are little helper tools you can use. You can just click through, for instance. Load the data. There's a menu item for that. I'll show you how to do it with a little bit of file commands. GetWD in RStudio tells what folder it's currently looking at. Get working directory is what that stands for. Then you either change where RStudio is looking or change where the data is. As an investment, it's probably good to have a folder called Echo B2000 or, something like that. And within that, then put little folders, lecture 1, assignment 1, household pulse data, something like that. Then put the data in there and tell R, hey, look for the data in the following folder. You can click through. You can do this in different ways. It's a multi-step process. You download the data. You put the data in the appropriate directory where you want R to go looking for it. Now we'll use household pulse data. In the Great Pandemic, the Census Bureau started doing a bunch of pulse surveys at a high frequency every few weeks. They'd go out and ask people a bunch of different questions. The questions changed over time as different things became a priority to know about. The data combines responses to 14 surveys done over the span from 2020 to 24. Bunch of demographic information so we can look, to what extent some of those other answers change depending on factors like a person's education level. Hopefully, you'll find this to be an interesting data set to work with. Census did a lot of work to put it together. I'd like you to pause and think about some questions because you want to be considering research ideas. Now, of course, it's early. You probably won't have anything clear, but indulge your curiosity. Ask, I wonder if, or I wonder why, this, that, and the next thing. So what does this data look like? After you load the data, you can look at it. Look at the first 10 rows of the first 6 variables I've shown there at the top. That's the square brackets there. 1 to 10, 1 to 6. Just gets an idea. Each row represents the answers from a person. So the first person is 34 years old, female, college grad, married, income midpoint of $62,500. Note the household pulse records not the exact income, but people select a band. So this person chose the band from $50,000 to $75,000. That number, 62.5, is just the midpoint of that band. There's a lot more data in the other variables. You can go through it in more detail. Next row, the row 2, somebody aged 34, male with some college but not a bachelor's degree, divorced, making 25 to 35,000 of income, white. Let's see, third row, age 44, etc., etc., etc. Now you could read through all 984,790 observations, but life is short. We want a kind of a summary. In our studio, that is exactly the command. Summary DHHP 2020-24. That gives you that summary. And you can mostly read through the summary statistics for each variable. They should be reasonably clear, age, gender, education. Education measure is pretty common. It asks about the person's education. It records the highest level that they've completed. Some people didn't go to high school. LT is less than. Some didn't even complete high school. That's some high school. Some folks got a high school diploma. Some people got some college but no degree. Some completed their associate degree or bachelor's degree or advanced degree. Marital status includes answers for married, widowed, divorced, separated, never married, and NA for not applicable. For some reason the person either refused to answer or gave an answer that didn't quite fit any of the other categories. Race, and if the person is Hispanic, number of people in the household, number of kids, number of adults in the household, if they have private health insurance or public health insurance, what kind of work they do, if they recently lost their job, then 4 different questions about people's mental health, asking if in the past 2 weeks they felt really down or anxious or worried or they lost all interest for things around them. So hopefully you'll find something in here that looks interesting that you want to explore. One of the early things we're going to be doing in class is to take a look at all this just a little more deeply.